Good morning, madam. Here is the presentation for assignment A from Group 17. My name is Tan Si Hui, matrix ID MA20150, and I will going to present about the first two questions. For question A, based on the above phenomena, the factor affecting the flow velocity of upstream and downstream river include the flow gradient and cross-sectional area. From the figure shown in the slide, we can see the upstream river have higher terrain and the potential energy and kinetic energy of the river flow are relatively high. So the flow velocity of at the upstream course is larger than downstream. Furthermore, the upstream area is steep, and so the river channel area is relatively small, and the frictional force is small, and the resistance to water flow also low. So in the contrary, the river flow area in the downstream area is larger, the friction force is larger, so that the resistance to water flow also large, so that it is clearly to see that the upstream velocity is higher than the downstream. And finally, the size of the flow channel area also can be based on the continuity equation, that is considering the upstream flow rate is equal to downstream flow rate, which is A1 V1 equals to A2 V2. And since the upstream area is smaller than the downstream, therefore the upstream velocity is greater than the downstream. After that is for question B. So based on the question B, we need to find the resultant force acting on the bent pipe. So first, we should figure the force direction, and based on the force direction that we figure, then we can form two equations, which is sum of the force for y direction and sum of the force for x direction. So we get that the Fy equation is P1 A1 minus P2 A2 cos 30 degree minus resultant force Y equals to density Q times V2 sine 30 degree minus V1. However, the sum of the force for direction x is 0 minus P2 A2 cos 30 degree minus resultant force x equals to density Q times V2 cos 30 degree. Next, after we form that two equation, next we will continue to find the value that we need in the equation. First, we find the area of the cross-sectional area, which is A1 equals to pi radius square equals to 0.07 meter square, and where A2 equals to 0.03 meter square. Then we apply the continuity equation to find V2, which is Q equals to AV, and where the A1 V1 equals to A2 V2. Then we substitute the value inside the equation, then we get V2 equals to 9.3 ms minus 1. After that, we use the Bernoulli equation to find the P2, and P1, which is P1 over rho g plus V1 square over 2g plus Z1 equals to P2 over rho g plus V2 square over 2g plus Z2. And here the value of Z1 and Z2 is equal to 0, so the equation will become P2 minus P1 over rho g equals to V1 square minus V2 square over 2g. So that we can substitute the value into the equation, then we get the P2 equals to 85.5 times 10 power 4 Newton meter over meter square. After that, after we find all the value that we need, which is area, velocity, and pressure, then we substitute into the equation. Then we can find the resultant force of Y, which is 406,977.5 Newton, and the resultant force of X, which is negative 76942 Newton. After we get the resultant force of x-axis and y-axis, then we can use this equation, which is resultant force equals to square root fx squared plus fy squared. Then we get the final answer, which is the resultant force equals to 4141 x6.86 Newton. And that's all for my presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nabila binti Zaini. My ID number MA20144. Okay, in this video, I will explain about my part in assignment 2A. Okay, the question is, a cast iron piping system deliver water at 20 degrees Celsius from lower tank to higher tank as shown in figure 2. Internal diameter of the pipe is 2.5 cm. The piping system has sharp interest, fully open globe valve, threaded smooth bands, meter bands, and bracket without vein, and 110 degrees Celsius, threaded return band and sharp exit. The values of K as shown in table 1. The total pipe length is 120 meter. Gauge pressure inside the upper tank is 2 bar. If water is delivered at 18 per min and the evaluation difference H is 100. Calculate the minor head loss. So this is the answer of minor head loss. Okay, the formula is Q equal to AV, V equal to Q over pi over 4 multiply D2, okay, equal to 4.166 multiply 10 the power of negative 2 over pi over 4 multiply in bracket 2.5 multiply 10 the power of negative 2 in bracket the power of 2. So you can get the answer 8.48 meter per second. So next we need to find V2 over 2G equal 8.48 the power of 2 over 2 multiply 9.81. So you can get the answer 3.67 meter. Okay, next you can find the minor loss. Okay, this is the formula. The answer is 13.663 meter. Okay, this is minor head loss. So next we need to find major head loss. Okay, you can see in this roughness 0.26 millimeter. Okay, relative roughness equal to 0.26 over 25, and you can get the answer 0.0104. Okay, Reynolds number, formula intensity VD over dynamic viscosity. So you can get the answer of Reynolds number. Okay, next you can from Modi chart you can find the friction factor. Okay, so major head loss, the formula is friction factor L over D multiply V the power of 2 over G, and you can get the answer of HL. Okay, next we need to find gauge pressure at the lower tank in bar. Okay, we need to apply Bernoulli equation at section 1 and 2. Okay, this is the formula. Okay, you can cancel out of these two parts like I do in this picture. Okay, so this is equal to 0 when you cancel out, and you can get the H 345.78 meter. Okay, next question is, imagine you are a mechanical engineer that are in charge in installing pipelines for storage piping system in an industrial zone. What should be the suitable type of flow meter that you may recommend to be used for the flow measurement reading? Explain your answer. Okay, this is my answer and my explanation. Okay, in this picture, this formula of HL equal to friction factor LV on the power of 2 over 2GD. Okay, you can see in this picture, I explained that what is VH friction LGD. Okay. So under the formula, I explained the industry plans and the importance. So that's all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq Ikmal bin Mustafa Kamal and my matric number is MA20130. So I will proceed for the question F and G. In question F, we know that the question need us to find the answer of calculate the volume flow rate of oil inside the conduit. So we gather all the information given from the question, which is D equal to 1 over 3D, LG oil equal to 0.95, P oil equal to 950 kg over m cube, CD equal to 0.98. So we use the equation of A equal to CD AO VO, and we calculate it, and we get the answer of 2.247 times 10 power of negative 3 millimeter cube per second. Next, for the F2 question, the question said that determine the mass flow rate of oil inside the conduit. So we use the equation of M equal to PV, and we get the answer 2.135 kg as negative 1. So for the F3, the question said that explain why discharge coefficient CD for the venturi meter is higher compared to the nozzle meter. So for venturi meter, it has a convergent and divergent cones, resulting in the less losses and higher discharge coefficient. For nozzle meter, it has a sudden contraction and sudden expansion, resulting in more losses and lower discharge coefficient. Okay, so I will proceed to the next question, which is G, and it is the last question. G1, Pitot formula to obtain the flow velocity. So we use the formula P1 over Pg plus V1 squared over 2G plus Z1 equal to P2 over Pg plus V2 squared over 2G plus Z2. So we calculate it, and the Pitot formula will sound like V equal to square root 2 in bracket P1 minus P2 over P. So for the next question, which is G2, the pressure difference inside the system, we use the P equal to rho GH, and we calculate it, and we get the answer 587.42 Pascal. So for the last one, which is G3, the question wants us to find the air velocity inside the system. So we need to use the Pitot formula that we have find in question 1, and we will get the answer 1.085 millimeter per second.
Okay, for the question A, D is 4.5 cm, small diameter is 2.15 cm, and the rho is 789 kg per meter cube, and for the mu is 0.0012 kg per meter per second, and the flow state is 6.2 meter cube per hour. For velocity inside pipe, which is V equal to flow state divided by area. We insert the value, and then we get 1.08 meter per second. For the Reynolds number, the formula is rho the formula of Reynolds number is rho VD divided by mu, viscosity. We insert the value, and then we get 31854.5. For the osmos is 0.0231, and then for the beta is the formula is the small diameter divided by diameter, and then we insert the value, we get 0.478. Next, we calculate the velocity in the orifice. V equal to velocity in pipe divide beta square. We include the value, and then we get 4.73 meter per second. Next, we calculate the height difference. The formula is H2 minus H1 equal to loss coefficient loss coefficient times V obvious divide by 2G, and then we get 0.11. Then we calculate, and the final height 2 is 1.41 meter. Then we want to find H difference of H3 and H2. The formula is F time length of pipe divided by diameter time velocity in square divide 2G, and then we get 0.14 meter. The final answer is 1.55 meter. So the conclusion is piezometer level at H2 and H3 is 1.1 meter and 1.55 meter. Thank you.